Okay, here we're going to talk about the law of cosines, and this is good for the geometric situation, angle, side, angle, or side, side, side. Now, before we jump into it, let's remember the Pythagorean theorem. So the Pythagorean theorem, remember, only works on right triangles, okay? Now, the side opposite of the 90 degrees is the hypotenuse. And so the Pythagorean theorem says c squared equals a squared plus b squared, right? But again, that only works for right triangles. In this section, we have general triangles. So let's say we had A, B, C as a triangle, and it's not necessarily a right triangle. So the Pythagorean theorem doesn't really apply. This side would be labeled C. The side opposite of angle A would be labeled A. The side opposite of angle B would be labeled B. Okay, now looking at angle C, the side opposite is little c. What we're going to do is, well, what the law of cosines does is generalize the Pythagorean theorem. Right? So this is the Pythagorean theorem. The law of cosines says c squared equals a squared plus b squared, just like the Pythagorean theorem. But you have to, it's not a right triangle, so you have to adjust by subtracting out 2 times AB times the cosine of the angle between AB, which is, in this case, angle C. Right? So this is the law of cosines. And look at the similarity, right? It very much looks like the Pythagorean theorem. Okay, now we went ahead and we did this for angle C, but you don't know that C, you won't know A, you won't know B sometimes, so you can actually apply the law of cosines to any angle. So looking at the side opposite of angle A, it's A. So we could treat A as the hypotenuse, right? So if I write it up this way, I could say A squared equals, now the legs would be B and C, so we'd have B squared plus C squared. Right? That's the Pythagorean theorem. Then we would adjust by subtracting out 2 times BC times cosine of the angle between P and C, which is A. All right, and so that's the law of cosines applied to angle A here. And then lastly, we could have applied the law of cosines here to angle B, in which case the opposite side would be little b, and that would be the hypotenuse. There's no hypotenuse here, but we could write b squared equals, right? The legs would be a squared plus c squared. And so we'd have to adjust by multiplying by 2 times AC times the cosine of the angle between those, which is b. All right, so there's actually 3 versions of the law of cosines. 1, 2, 3. You'll see that in the book. Now let me show you how to use them. Okay, now here's our example. Let's go ahead and draw a triangle, just a general triangle here. Let's say, don't worry about drawing this to scale, ABC, but it's not necessarily a right triangle. Here, C is given to be 36 degrees, A is 10.5 units, and little b is 11.8 units. So when you look at this triangle, you can see the given situation really is a side angle side. Right? You have 2 sides and an angle between them. When that's the case, you're going to want to apply the law of cosines. If you try to apply the law of sines, you're going to run into difficulty with 2 variables. It doesn't work. All right, so here we have to find A, we have to find angle B, and little c. Those are the unknown values. Okay, so you start the law of cosines by looking at the given angle and the side opposite. That's what we're going to treat as the hypotenuse. So if this were a right triangle, we could say c squared equals a squared plus b squared. So 10.5 squared plus 11.8 squared. Now this is not really a right triangle, so that's not correct. We have to adjust by subtracting out 2 times a, which is 10.5, times b, 11.8, times cosine of the angle between these functions, which is 36 degrees. Okay, so that is the law of cosines. Okay, so now from here we just do it on a calculator, right? We do this calculation. So we have c squared equals 10.5 squared. Okay, so I did that on a calculator and I got 49.0. Now that's what c squared equals. So at this point what we're going to have to do is take the square root. It's really plus or minus, but we're going to disregard the negative answer here and say c is approximately equal to 7.0 units. All right, so we found c just applying the law of cosines. All right, so I can go ahead and I can put that in there now. So now I know this is approximately 7.0 units. Now I need to figure out angle A and angle B. At this point, I can apply the law of sines, certainly because I have side-side angle, or I can just apply the law of cosines again. Either way, I prefer to apply the law of cosines again, because the law of cosines, it never really introduces any kind of ambiguous case, so I think it's easier. If I want to go for angle A, I want to look at 10.5 as the hypotenuse. So if I were going to set up the law of cosines for angle A there, I would say the hypotenuse, 10.5 squared, is going to be equal to, right, the legs, which are 7.0 squared plus 11.8 squared, right? And then I would adjust by subtracting out 2 times 7.0 times 11.8 times cosine of the angle between them. And the angle between those two legs is A. Right? And so that's an application of the law of cosines for angle A. All right, so this one's a little bit different because notice here the variable is inside a cosine, whereas on the previous application the variable was the c, right? So when the variable is inside a cosine, we're going to have to eventually do some sort of like cosine inverse or something. All right, and so let's do some algebra and go ahead and isolate. What we want to do is isolate that cosine. All right, so what we'll do is we'll subtract 7.0 squared and we'll also subtract 11.8 squared. All right, and that'll be our first thing to do. So we have 10.5 squared. We could do that on a calculator, minus 7.0 squared minus 11.8 squared, and that's going to equal negative 2 times 7.0 times 11.8 cosine of A. All right, and then at this point, we have multiplication right here, so what we'll do is divide by all this stuff here. Negative 2 times 7.0 times 11.8. Both sides. All right, and that gives us 10.5 squared minus 7.0 squared minus 11.8 squared, right, divided by negative 2, 7.0 times 11.8. And then on this side, all this cancels, and so I just get cosine of A, right? So I did the algebra and I got cosine by itself, right? Isolated the cosine. All right, and then so at this point, we'll take cosine inverse of both sides. Now, it turns out you don't have to worry about using cosine inverse. You don't have to worry about two solutions. That second solution will always be too big. So there's never any ambiguous case. You can trust your calculator just by typing in cosine inverse of that ratio. So I'm going to do that now. I'm going to type this straight into the calculator. If you want, you can do the inside calculation first and then hit the cosine inverse, but you can try it. Either way, we're going to get A is approximately equal to. And so I get approximately 61.8. That's an angle. I am in degree mode, so 61.8 degrees. Okay, so let's go back to our original. We're trying to solve this triangle, so we just found angle A to be 61.8 degrees, so I can put that in there. And then to find the last angle B, that should be pretty easy. We know all the angles of a triangle have to add up to 180, so I'm just going to take 180 minus 61.8 minus 36, and that leaves me with angle B, which is 82.2 degrees. Awesome, so here we were given side angle side. That's the values here in black. And then we were able to apply law of cosines twice to get the missing sides. All right. Okay, so you can see these are a lot of work. Take them slow. Law of cosines here. So A, B, and C. So this time little a is given to be 11. Little b is 16. The length of the side C is 9. And so looking at this geometry, you can see that they gave us side, 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 right? They gave us all the sides. All right, and so we need to find the angles. Given all the signs, you can actually find the angles. Law of sines isn't going to work. So what we're going to do is apply the law of cosines. I'm going to start with angle A and consider the side opposite as the hypotenuse. All right, so this is the given. So applying the law of cosines, I would say that hypotenuse, 11 squared, equals a squared plus b squared. So here's my sides, 9 and 16. So 9 squared plus 16 squared, right? A squared plus b squared equals c squared kind of thing. But this is not a right triangle, so we're going to subtract out 2 times 9 times 16, those are the legs, times the cosine of the angle between them, in this case, which is a. All right? And so notice the only variable left here is a. I should be able to solve for that. And so we'll go ahead and isolate that cosine first by subtracting 9 squared on both sides, and then subtracting 16 squared on both sides. Now you can do this now or later, it doesn't matter. I'm going to choose to do it later. So I'll just leave it as 11 squared minus 9 squared minus 16 squared equals negative 2 times 9 times 16 cosine of A. Okay. Again, I can make that calculation if I want. But I'm just going to finish up the algebra here. So dividing by negative 2 times 9 times 16 should isolate cosine. Okay. And so on this side, it all kind of cancels, right? And I'm left with cosine of A, and that's what I want. On this side, we have 11 squared minus 9 squared minus 16 squared, all over negative 2 times 9 times 16. Okay? To get A by itself at this point, we'll apply cosine inverse to both sides. And so we have cosine inverse of this fraction, 11 squared minus 9 squared minus 16 squared, all over negative 2 times 9 times 16. I can actually do this calculation on a calculator, but I prefer just to type it all in one swoop. Now, yes, this does have two answers, but law of cosines, that second answer will always be too big for a triangle. So you can trust your calculator when calculating the law of cosines. That's why I like the law of cosines. There's no ambiguity, no quadrants to worry about. All right, so let me do that on a calculator. Okay, I get 41.4 degrees. All right, so going back to my original, let's see here. We just found angle A. So let me erase that. We just found this to be, what did I say? 41.4 degrees. Awesome. Okay, now at this point you can apply the law of sines. You can do that's fine. But I prefer the law of cosines because there's never ambiguity. So what I'll do is run the law of cosines off of angle B. So this time I'll treat 9 and 11 as my sides. Okay. So, whoops, I'm going to have to scroll off the screen. Sorry about that. In this case, I'll write, try to squeeze it in here, 16 squared equals 9 squared plus 11 squared, right? 16 squared is the hypotenuse, so c squared equals a squared plus b squared kind of thing, right? And then I'm going to, it's not a right triangle, so I got to adjust by subtracting out 2 times 9 times 11 times cosine of the angle between them, which is b in this case. Okay? I don't know. Try to get that triangle on the same page there. All right. So there's the second application of the law of cosine. So we'll go ahead and solve this. All right, so the first step is to subtract 9 squared and 11 squared on both sides. And we get 16 squared minus 9 squared minus 11 squared equals negative 2 times 9 times 11 cosine of b. Okay, and then dividing, we get 16 squared minus 9 squared minus 11 squared. It's kind of tedious. 2 times 9 times 11. I'll tell you though, the law of cosines is much easier to work with than the law of sines. I mean, it seems like it's more work, but without having to worry about quadrants, that saves a lot of time. So we have negative 2 times 9 times 11 equals b. So at this point, right, I took cosine inverse of both sides. So I'll make that calculation on a calculator. Okay, and I get approximately 105.8 degrees. All right, so I found b. So I found a using the law of cosines. I found b using the law of cosines. So let's go back to our picture and let's put that in. Oops. So this was a 9. And then I got 105.8, so that goes here. 105.8 degrees. And then to find c, you don't have to run the law of cosines again. You can just use geometry. All those angles have to add up to 180. So 180 minus 41.4 minus 105.8, right? That's 32.8 degrees. That's just using regular geometry. So there we have it. Given all the sides, right? Given side, 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 we were able to find all the angles using the law of cosines. Awesome.